So for our project, we are doing question number 5, which is asking us, in the circuit shown, a real battery with EMF 6 volts and internal resistor 2 ohms is inserted between points A and B. What is the voltage difference between points A and B? So this is what we're being asked to find, which is what is the voltage difference between points A and B. We're given the battery with EMF of 6 volts and an internal resistance of 2 ohms. First off, we're going to calculate the equivalent resistance. To start, we need the equation for resistors in parallel, which is as shown there. So we're going to calculate it one by one for each resistor in parallel. So you get 1 over 44 plus 1 over 77 is equal to 121 over 3,380. Remember to invert it, and you get 28 ohms. For the second one, you get 1 over 55 plus 1 over 66 is equal to 121 over 630. Always remember to invert, and you get 3,630 over 121, which is equal to 30 ohms. For the third, you get 1 over 56 plus 1 over 40 is equal to 3.5 over 140. Inverting it, you get 140 over 3.5, which is equal to 40 ohms. So this is what we get. So we get 28 ohms for that resistor, 30 ohms for this resistor, and 40 ohms for this resistor. Now we have to find the equivalent resistance for it in a series, which you get is 28 ohms plus 30 ohms plus 40 ohms plus 2 ohms, because we have to remember to include the internal resistance, which gives us 100 ohms. The second step is to solve for the current. The formula for current is I is equal to voltage over resistance. So I is equal to 6 volts over 100 volts, which gives you 0.06 amps. The third step is to find the voltage across each independent resistor. So we get V is equal to 1 over R1 plus I is equal to times R2 plus I times R3. So you get something that looks like this, which is V is equal to 0.06 times 28 plus 0 times 0.06 times 30 plus 0.06 times 40, and you get 1.68 volts plus 1.8 volts plus 2.4 volts is equal to 5.88 volts, which is the voltage difference between points A and B.